So from here on out, we're going to be in the Climate Engine app for our next two demos. And this first one is going to be focused on invasive annual grass treatments in the Southeast Oregon Wildfire Resiliency Project. Just a little bit of background on this project. In the early 2010s, there were several large wildfires that burned in this region. And so that led to a pretty big collective response between agencies, different community groups, and the formation of a wildfire collaborative to try to tackle this problem. It was pretty widely recognized that the wildfire risk had increased as a result of invasive annual grass or annual grass invasions, which led to an increase in fuels. And so this group was meant to kind of address that that threat at a landscape scale. Beginning in the late 2010s, this Stinking Water Mountains project, which the Stinking Water Mountains, just a really colorful, wonderful name, was started to come into focus. And this group was able to go after funds to do some fuels treatments after the Oregon Senate passed extensive funding for wildfire preparedness, of which this group was able to get some of that funding. And that resulted in the ability to start to apply broad-scale treatments of cheatgrass and medusa head that are quite conspicuous in the satellite data. And so that's what we're going to be focusing on here in this demo. In particular, this kind of info box inset kind of window shows you the area we'll be focusing on. These are called the South Pasture treatments, which were applied in 2022. I am at this point going to jump into the app, but I do just want to highlight, we're going to share the slides after this session. And so you'll be able to find links and information on everything I'm going to show in the app. So we'll have some background maps, and then we'll have some examples from the pre-restoration period. There are more links here than I'll show in the demo. And then we'll assess restoration outcomes for this area in a couple of different ways. Again, these kind of references are for your reference to review later. So with that, I'm going to jump into the app. Okay, so this is our our area where we're going to be looking, and just to orient a little bit to the changes that we've made in the app that Kristen talked about earlier. The biggest changes you'll see from our first session with you all back in June are that we updated these menus up at the top of this window. So we now have a base maps option, a computed map, and map overlays. Under base maps, that's where we're going to find all of the high resolution imagery and topographic layers. So I'm going to start by turning on this historical imagery for this area. There aren't a ton of changes across this landscape that are super apparent here, at least not for the area we're interested in, kind of in the center of this image. Although we can see this Easter Day reservoir that has come in since this imagery. So we'll look a little bit more closely at these here momentarily, but before we get there, I want to show where you can turn on, for example, the land ownership layer. And so I will turn that on. Oop, got too impatient and turned it off and then turned it back on. Let me toggle back. Okay. There we go. So here we can see land ownership across this particular area, and can see that in large part this is BLM managed land. It's taken just a minute to to load there. If you have questions about the classes that are showing up in the map, we do have a legend in this map overlays drop down. So I'm going to turn off that layer for now. And I do want to look at the high resolution, more recent imagery here, because we'll start to see some interesting patterns on the landscape. When you turn on a layer like the NAPE True Color imagery, it'll tell you what years of imagery are available here, and then you can select from the drop-down how you want to view, what year you want to view. And I think I have that layer turned down, so if I turn it up, there we can see that 2004 NAPE imagery. If we jump to 2009, they'll just kind of jump through the imagery. By the time we get to, think about 2012, we start to see these kind of patterns on the landscape that are starting to pop out and are pretty persistent as we look through the data. So we can see these areas of kind of lighter hued vegetation. We want to be a little careful interpreting NAPE because it's collected at different times of the year and different years, but these are pretty persistent patterns that we're seeing throughout the time period. So it's pretty likely there's some sort of change happening there. Okay, so those are some of the new layers, and now I want to jump into using data sets like the RAP and RC map to investigate some of these changes. To do that, you'll remember we can find those data sets in the remote sensing option. And then all of our derived products are available down at the bottom of our products list. So we'll start by looking at the RAP cover data here. Okay, let me get situated here and make sure I can follow along. Okay. What I want to do first is look at annual forb and grass cover during the pre-restoration period. So I'm going to create a map of average annual forb and grass cover. So I select average conditions here from the calculation dropdown. And I'm going to take a 3-year period. That's pretty helpful to do with data sets like this, like the RAP, because especially with annual forbs and grasses, they can vary quite a bit from year to year. So taking a 3-year average gives you a better picture of kind of how extensive these different vegetation types are on the landscape. And now we start to get quite a bit more insight about the fact that it appears that annual forbs and grasses are kind of dominating these areas that we're seeing. I'm not going to show RC map right now but we have examples with RC map in the slides. So if you'd like to see that, go ahead and look there. I do want to look at the RAP 10 meter for the same period. And the reason I want to do that is because it's specifically mapping invasive annual grasses. And so we'll get a lot more clarity about whether this is in fact an invasion or some sort of, native plant, perhaps. And in fact, we do see, according to these maps, that this looks like a pretty extensive plant invasion across this area. The next thing that we might want to look at goes back to some of the examples that Ken showed. So I want to look at not just, this is kind of getting at pre-restoration status. What I want to get at is longer term trends. So I'm going to go back to the 30-meter data. Remember, that goes back to the mid-1980s. And so I want to, here, instead of average conditions, map slope of trend. And I'm going to select the entire period of record prior to the treatments in 2022. It sometimes takes a minute for the map to come back. And we can see pretty clearly, oh, I'm sorry, I'm looking at the wrong layer. I need to turn this to annual forbs and grasses. And so now we can see really clearly as that map's coming back that, in fact, a lot of this area that we're interested in has had increasing trends in annual forb and grass cover over this area. If you want to do the kind of filtering like Ken was showing during his demo, we can apply this 95% confidence interval mask to the map. And when that comes back, we'll see only trends coming back that are above a 95% confidence interval. Seeing a little bit of taking a minute to come back. It's good to remember that there's a lot of data being pulled in on the fly. But you begin to see pretty clearly that a lot of this area has been trending positive in terms of annual forbs and grasses. All right, so that is what I want to show, I think, for the period. I do have another link for a time series figure in the slides. So I will just open that up and I'll show how to create a similar time series figure for the post-restoration period. But what this is showing is, and you can change the y-axis labels. They'll come back sometimes different. But this is showing RAP and RC map over some of the more invaded parts of this landscape, showing that increasing trend and upwards of 50 to 70% tree cover during that pre-restoration period. So what I want to do now is start to look at how we can quantify, this. Okay, so that sets the stage, right? These might be steps you go through in the planning process for a project. Now we want to try to quantify outcomes. And so what I'm going to do is switch over to the RAP 10 meter data. And I want to compare, okay, this treatment went in 2022. I want to look at a recent year. So we'll create a map of 2025 compared to the pre-restoration period from 2018 to 2021. So the way we can do that is I'm going to select invasive annual grasses as the variable. And then we can use this difference from average conditions map. And if I select the most recent year I'm interested in, and we select 2018 to 2021 as the year range for the historical period, we will get a map that has a lot of colors. So one thing you'll notice, just backing up for a minute, is that this color ramp is pretty saturated. So we apply some kind of default limits to the color ramp. You can also change your color ramp here if you want something different. I'm going to stretch this a little bit. I'm actually going to stretch it a lot, and we'll see. Set the limits at 40% and negative 40%. And now we see much more clearly the effects of this treatment on the landscape. If you want to see kind of particular values within the map, you can use this get value button, and that will help you pull down individual values. But this becomes a pretty powerful way to start to quantify the effects of this treatment. The last thing I'll move into here is showing you how to pull some time series data for this area. So I'm going to first pull, oh, I'm sorry, so we have a shapefile for the project treatment area here. You can upload that by selecting this custom polygon option. And I have it on my desktop. It is this one here, South Pastures, Invasive Annual Grasses. We can see a lot of kind of surrounding areas are included in this boundary, but kind of this core area is also included. I should say you select your, let me refresh this here real quick. All right. Skipped a step. You can select which column from your shapefile to select from. And now I can select, there's only one polygon in this shapefile, so it doesn't make a big difference. But what I can do now is click Compute Time Series, and The RAP 10 meter data were already selected. Oh, why? I think because my form is messed up over here. Okay. Now let me click compute time series. And so we can see that declining trend over our area of interest, over this polygon in the RAP 10 meter. And this is where we can bring in some more context and view the RAP 10 meter alongside the RAP 30 meter, which is going to give us a much deeper time series. And so, as I mentioned, the kind of by design, the different y-axes will be on different scales. And so here we can see that these data sets are both showing, an increase. Well, RAP 30 meters is showing an increase for the historic period, and then they're both capturing the effect of this treatment in 2023 through 2025. And so I think this already depicts the impact pretty well. But the last thing that we can show is, oops, I'm all the way zoomed out now. Let me zoom back in on my area. Okay. Kristen mentioned the masking that we can apply earlier in this session. So the National Land Cover Database is pretty interesting for this area in that it picks up those most invaded areas as a grassland compared to the surrounding area. So what we can do is use that to analyze only those grassland pixels and see the effect of the treatment in those grassland areas. So here what I'm going to do is for each of the variables, I have to use this new masking option. And then I can mask by category. All of the layers shown here are the same ones that are shown here. So you can kind of visually inspect them in the map as you're selecting them in this dropdown. And I'm going to select National Land Cover Database. And then I'm going to scroll down to grassland and herbaceous. And then for variable 2, I will apply the same mask. So I'm going to select National Land Cover Database. And go down to grassland and herbaceous, click compute time series. And now we get a pretty dramatic map back. We can really clearly see by focusing on that most invaded area how severe that invasion was, with upwards of 50 to 70% cover mapped over that kind of peak period. And then we can see a pretty promising decline after this treatment. And so as you can see, we've gone through how you can kind of characterize the pre-restoration period for the planning process, and then different ways that we can kind of focus our analysis on the portions of the landscape we're interested in for characterizing outcomes of restoration. So that's what I have for this. Again, we have links for most of the figures created here. A couple of them, we have some limitations on the types of links you can create, but hopefully this will be enough to walk you through how to perform this type of analysis elsewhere. And with that, yeah, I think we have time to see if there are a couple questions. Yeah, Tim, I have not been watching the chat, so.
That's okay. Yeah, it's mostly me throwing out comments as you guys are talking. So I know sometimes there's a lot to take in, and we don't always want to, ask questions in front of others. There'll be more opportunities for that with smaller groups. We'll talk about that toward the end. One thing I wanted to point out is Eric has utilized a couple of times the link function in the Climate Engine app. And that's where you can generate an analysis, you can generate a link, and then you could share that link with someone. And as long as they're registered for the Climate Engine app, once they sign in, it'll open up that same analysis. So really pretty powerful if you want to collate a bunch of things to then show a coworker or something like that for a meeting. Eric, it doesn't look like we have any other questions right now otherwise, and you made up a little bit of time here. We're still running about 6 minutes over. So I'm going to let you, or I'm not sure who's doing demo 3, if it's you or Kristen.
Yeah, I think we're in good shape.
Oh, okay.
I'll be doing demo 3 and yeah, try to make up a little bit of time here, but
Excellent.
I think we're doing okay.
I might take a moment
Yeah,
then to mention a couple of other things. As I put in the
please.
chat, the RAP 10 meter now has the 2025 data. We expect that to come out for the 30 meter in sometime next month. Our CMAP usually produces that data around the same time, although that's a little bit subject to change, especially this year, as some things are a little bit abnormal, but that'll be coming out very soon. I think Eric made a really nice example there, how he showed how you could contextualize the RAP 10 meter data with the RAP 30 meter data. And if there is a publication out on the RAP 10 meter data, if any of you are interested in that, I'd be happy to send it along or provide more information. In short, it has the same plant functional types as the RAP 30 meter, but then there are a couple of additional plant functional types, namely pinon juniper, invasive annual grasses, and sagebrush. So that product goes from 2018 through present. In the immediate future, both of those will continue to be generated for both of them. And so obviously pros and cons to both. As you can see, the way Eric used them to provide those multiple lines of evidence, I think is pretty important.
Yeah, it's a great point. And the 10 meter data are really new, as Tim said. And so I think one of the things that we've talked about quite a bit is to make it clear that the 10 meter aren't, better than the 30 meter. I think sometimes we think that high resolution data are kind of just better. And that can be true depending on your question. But we have 30 meter data going back much further. And so if you start trying to think about some of these questions about, well, how do I apply these data side by side for some of my questions? I know those are the types of things that Tim, really tries to support. And I think just to know that a lot of that is really new. And I think everyone the community is kind of grappling with, how best to kind of, what types of questions each of these data can help to address. So let's jump into our third demo.